What lies hidden behind a hypothesis so disruptive about Planet 9? In 2016, scientists Mike Brown and Konstantin Batygin identified a group of distant objects, ETNOs, with strange orbital alignments, whose probability of occurring by chance is extremely small. There, the laws of physics appear to be bent by an invisible force. The object responsible for this clustering would have to be a massive planet, estimated to be 5 to 10 times the mass of Earth, pulling and twisting icy bodies into an order that defies explanation. But when scientists identified a potential candidate, an object whose mass and faintness appeared consistent with Planet 9, everything turned out differently than expected. The orbit of this candidate appeared to run backward, tilted by nearly 120 degrees relative to the plane of the solar system, contradicting the gravitational influence previously assumed. So, where is Planet 9 really located? Right now, let us step into the journey of unraveling the mystery known as Planet 9. The story begins in 2016 when two astronomers at the California Institute of Technology, Mike Brown and Konstantin Batygin, published a groundbreaking study based on mathematical simulations and orbital data from 6 distant celestial objects, extreme trans-Neptunian objects, ETNOs. They discovered that all of these objects had a point where they came closest to the Sun, almost aligned in the same direction in space. The probability of this occurring by chance is only about 0.007%, according to Newton's laws. Every object in the solar system is subject to gravitational forces from the Sun and other large planets. To verify this phenomenon, the research team ran thousands of dynamic simulations. The results showed that by adding a planet with a mass 5 to 10 times that of Earth, orbiting the Sun at a distance of 400 to 800 astronomical unit, with an inclination of 15 to 25 degrees, the orbital anomalies could be fully explained. This planet, named Planet 9, has become the most intriguing hypothesis of the 21st century. Normally, objects at the edge of the solar system would have random inclinations. However, the ETNOs group discovered lies within a relatively stable plane, inclined about 30 degrees from the Earth's orbital plane. This indicates a resonance between the smaller objects and a larger controlling force. Another clue is the presence of objects with retrograde orbits, moving in the opposite direction of the other planets. One example is 2015 BP519, discovered in 2018 by astronomer Juliet Becker's team at the University of Michigan. This object has an orbit tilted over 54 degrees. which cannot be explained by the gravitational influence of known planets. Moreover, dynamic models also suggest that Planet 9 not only influences small objects, but also affects the long-term stability of the entire solar system. This explains why some objects, like Sedna, have orbits that stretch tens of thousands of years yet maintain stable shapes, something that would be almost impossible without gravitational control from a large object. A prime example is 2015 TG-387, discovered by Scott Shepard and Chad Trujillo. It has a perihelion of 65 AU and an aphelion of over 2,000 AU, inclined by 11 degrees. Its orbit matches almost perfectly with the predicted model. If a large Planet 9 exists at around 600 AU. Running dynamic simulations, Shepard found that 2015 TG-387's orbit was much more stable with Planet 9 in the system. If Planet 9 truly exists, it would be a completely new type of planet in the solar system. A type common in other star systems but missing from ours. This suggests that Planet 9 could be the missing piece in planetary formation, having been ejected during the chaotic early stages. Thermodynamic models predict that if Planet 9 has a mass 6 to 10 times that of Earth, it would have a core of ice and rock, surrounded by a thin hydrogen and helium atmosphere. At a distance of hundreds of AU, its surface temperature would be around -230 degrees Celsius, causing visible light to reflect very weakly, but it would still emit faint infrared radiation. This is why scientists are searching for it with infrared telescopes rather than optical ones. Is this evidence of a real planet? Or is it just a statistical illusion? The answer lies in its origin. If Planet 9 exists, where does it come from? Does it originate from the early solar system, or is it a wanderer captured from another star system? The next part of the journey will take us back 4.5 billion years to a time when the solar system was still in chaos, to trace the origins of the exiled planet. If you're interested, click subscribe to WUFO now, so you won't miss our next discoveries. About 4.5 billion years ago, the solar system was in its first chaotic phase, where massive planets constantly exchanged energy and orbits through colossal gravitational collisions. According to the traditional planetary formation model, approximately 600 million years after its formation, the giant planets in the solar system moved dramatically from their original positions. Jupiter and Saturn, due to resonance interactions, are believed to have caused the late heavy bombardment, a phase where billions of small celestial bodies collided with the planets in the solar system. If this is true, Planet 9 is the exiled planet from this early chaos period. Scientists tested this hypothesis using millions of simulations. Moreover, the existence of a giant planet at a far distance not only makes sense in terms of dynamics, but also helps explain the resonant orbits of trans-Neptunian objects. The presence of this planet creates a three-dimensional resonance gravitational field, keeping small objects stable for billions of years, similar to how Jupiter keeps the Trojan asteroids. Many astronomers refer to this as the gravitational scar, the remnants of the past collisions and energy exchanges during the planetary formation phase. If we can pinpoint the exact location of Planet 9, we will not only discover a new planet, but also confirm the violent past of our very own solar system. But there is a more bold and intriguing scenario. Planet 9 may not have originated in the solar system. It may have come from outside. If this is true, it could explain why its assumed orbit has an unusual tilt of 15 to 30 degrees and a high eccentricity, characteristics that do not align with the conventional planetary formation process within the solar system. Some models even suggest that Planet 9 could have once been the second planet of a binary star system, ejected after the companion star to the Sun disintegrated. While this hypothesis remains unverified, it serves as a reminder that the edge of the solar system may hold ancient memories of the Sun's past as a binary star. To distinguish between these theories, scientists focus on the material composition and thermodynamics. If Planet 9 is indeed an exiled planet, it would likely have a composition similar to Uranus, primarily made of water ice, ammonia, and methane, with a small rocky core. This structure would emit faint but stable infrared radiation. On the other hand, if it is an exotic planet, it would likely have a higher density and lower internal temperature, having formed at a greater distance from its original host star. It could also contain rare isotopes of oxygen or carbon, a chemical fingerprint indicating an exoplanetary origin. However, to confirm this, direct infrared spectral observations are necessary, which current telescopes are not sensitive enough to perform. Regardless, both hypotheses share a common point. Planet 9 is not a random object. It is the result of a complex gravitational interaction, a testament to the dynamism of the early solar system. Satellites such as WISE, Akari, and IRAS have recorded billions of infrared light sources, many of which have never been thoroughly analyzed. These data are currently being reviewed using artificial intelligence to find slow-moving light sources, a sign of distant objects. Research groups, like Terry Longfan's team, have detected slow-moving infrared candidates with orbits beyond 500 AU, but most remain unverified. These objects could be brown dwarfs or rogue planets not associated with the Sun. However, each new discovery makes the Planet 9 hypothesis more plausible. If not one, perhaps several small planets or massive objects are hiding at the edge of the solar system, contributing to the anomalies we observe. The gravitational fingerprints once hailed as evidence for the existence of Planet 9. But what if all of that evidence was merely a statistical illusion? Over the past decade, astronomers have discovered dozens of distant objects beyond Neptune, known as extreme trans-Neptunian objects, or ETNOs for short, with bizarre orbits that create a gravitational fingerprint that has sent the scientific community into a frenzy. These objects share similar orbits, with perihelion points and inclinations aligned in nearly the same direction, leading many to believe that a massive planet, Planet 9, could be influencing these orbits. But could this be evidence of Planet 9's existence, or merely a statistical illusion based on our observational limitations? The issue rises from what scientists refer to as a data trap. Telescopes like Subaru in Hawaii or the Dark Energy Survey in Chile can only observe a small portion of the sky for limited periods of time. This leads to incomplete observations, focused only on areas that are easier to survey. Astronomer Samantha Lawler, a member of the OSOS program, notes, "If Planet 9 truly exists, we should see its effects in unbiased data." Statistical simulations have shown that the likelihood of these orbits clustering randomly is about 15 to 20%, much higher than the 0.007% previously suggested by researchers. This calls into question the validity of the Planet 9 hypothesis. With only around 30 to 35 ETNOs discovered so far, the sample size is too small to make any definitive conclusions. If newly discovered objects have reversed orbits, the clustering model could collapse entirely. The scientific community now faces a significant question. Does Planet 9 truly exist, or is it merely an illusion created by the way we observe? With the launch of the Vera Rubin Observatory, the largest sky survey in history, we may soon find the answer. Rubin may be able to detect any objects larger than 100 kilometers at distances up to 1,000 AU. If Planet 9 exists, this will be a breakthrough in our exploration of the cosmos. If not, it will remain nothing more than an illusion, a data error, and a belief in something we still don't fully understand. So, what is Planet 9? A massive planet hidden at the edge of the solar system? Or simply a legend created by the limitations of our observational tools? In early 2025, an international research team led by Terry Fan published an analysis of data searching for faint infrared sources that move extremely slowly, potentially being a cold and distant planet that visible light could not detect. But the heat emitted from the planet itself is still enough to shine in the far infrared range. This is why the research team took a different approach. instead of searching for light, they searched for heat. IRAS and Akari data revealed faint light sources appearing at different positions over 2 observation periods. "23 years apart." Its radiation falls within the 25 to 60 microrometer range, which matches the thermal emissions from the core of a cold, icy planet. Where residual energy from its formation still leaks into space. When the results were published, the astronomical community was shaken. If this object truly exists, it could be the first visual evidence of the long-lost Planet 9. Predicted by Mike Brown and Konstantin Batygin through gravitational equations nearly a decade ago. When the research team used the 2 IRAS and Akari observation positions to calculate the potential orbit. They found that the orbital inclination of this object exceeds 110 degrees. And its direction of motion is entirely opposite to the rest of the solar system. According to Brown and Batygin's model, Planet 9 would need an elliptical orbit. Tilted about 15 to 25 degrees and located approximately 400 to 800 AU from the Sun, to keep the Etnos within a stable structure. Another scenario was also proposed. Perhaps this is a brown dwarf at the edge of the solar system. If its mass exceeds 13 times that of Jupiter. Then it would no longer be Planet 9, but rather a second star orbiting the Sun in the darkness. Similar to the Nemesis star hypothesis put forward in the 1980s, to explain the periodic mass extinctions on Earth. Scientists estimate that at least 9 more observation points are needed to calculate the true semi-major axis, eccentricity, and orbital period. The scientific impact and the open question, if this object is real, it could rewrite the entire history of the solar system's formation. A retrograde planet could prove that the Sun once captured many objects from other star systems in its early days when it was still in a stellar formation cluster. This would also mean that the boundary of the solar system, the Oort cloud, is not just home to comets. But could also harbor lost worlds drawn in. On the other hand, if this is a false signal, the discovery is still incredibly valuable. It reminds us that ancient data, when processed with modern technology, can lead to revolutionary discoveries. Infrared light not only reveals new objects, but also opens up another method to see planets. That the human eye could never observe. The astronomical community is now preparing to track this candidate using the Subaru telescope and dark energy camera. Two instruments capable of detecting movements smaller than 0.5 arcseconds per year. Meanwhile, the Vera Rubin Observatory, when it officially begins operations in 2026, will capture the entire southern sky with unprecedented depth and accuracy. If this object exists. Rubin will likely detect it within the first few months of observation. In early 2025, the infrared candidate left the astronomical community perplexed, and as the data gaps remained unfilled. The scientific community began to focus on one final hope. That hope was the Vera Rubin Observatory. A powerful astronomical observatory capable of rewriting the solar system's map. Located at the summit of Cerro Pachón in Chile, Rubin is designed to scan the entire southern sky every 3 nights. Using a 3.2 gigapixel digital camera to collect detailed data on slow-moving objects. Including those on the edge of the solar system that conventional telescopes can't detect. Rubin's legacy survey of space and time. Lasting for 10 years, will produce billions of cosmic frames. Recording every subtle movement, from comets to distant objects beyond Neptune. Equipped with the ability to detect objects so faint that they reflect only a fraction of a billionth of the sun's light. Rubin will be capable of finding objects that once only existed in theory. If Planet 9 truly exists, with a mass 5 to 10 times that of Earth, and located between 400 to 800 AU, it would move extremely slowly, around 0.3 degrees per year. With the ability to detect even the smallest movements, Rubin could detect Planet 9 within 10 years. Provided it moves slowly enough for Rubin to observe. Renowned astronomer Mike Brown has affirmed that if Planet 9 exists, Rubin would be the tool to find it. Visit oceansa.org and sign up, and then click What makes Rubin special is not just its size and observational capabilities, but also how it sees the universe. Using multi-band sensors, Rubin can analyze light from ultraviolet, visible, and near-infrared wavelengths. Helping detect objects with differing light spectra, traits that could point to a cold planet like the hypothetical Planet 9. However, one of the biggest challenges Rubin faces is the galactic background noise. In the distant regions beyond 500 AU, Planet 9 would have to move through millions of other stars. Making it easy to be washed out. To address this, Rubin uses a pipeline data processing that combines artificial intelligence and deep neural networks to distinguish between stationary stars and slow-moving objects. This system can detect movements as small as 0.01 arc seconds per year. Equivalent to spotting a person walking from a distance of 3 million kilometers. Nevertheless, the big question remains. If Rubin finds nothing, could Planet 9 just be an illusion created by incomplete data? If no objects match the predicted orbit and mass. Alternative theories will emerge. One such theory is the large material disk hypothesis, suggesting there might be a small icy ring at the edge of the solar system creating an aggregate gravitational force that pulls objects into the same direction. Like a giant planet. Another theory, the modified Newtonian dynamics. Proposed by physicist Mordechai Milgram, argues that gravity in the far reaches of the solar system might operate differently than what we know, particularly at low accelerations. Despite many unanswered questions, Rubin offers hope. Over its 10-year mission, Rubin will capture more than 500,000 sky images and store up to 60 petabytes of data. This is an unprecedented scale-space experiment. Using powerful supercomputers to process and analyze the data. Other telescopes, like Subaru and JWST, will be called upon to verify any objects Rubin detects. Opening up opportunities to uncover mysteries never explored before. If Rubin finds Planet 9, it would be the first planetary discovery since Neptune was discovered in 1846. But if nothing is found, it would close a long chapter in the history of astronomy, ending a decade of debate. And ushering in a new era of understanding gravity and the universe. The Vera Rubin Observatory is not just an observatory, it's the final hope. The torchbearer that illuminates the path between belief and truth. It will help humanity take a step closer to understanding the solar system and the vast universe. As the blurry images emerge, one question will remain. Will Planet 9 appear in these images? Or will it remain the shadow of an untouchable scientific dream? Rubin will be where the answer is given, where the universe speaks. And the truth is illuminated in the darkness. Planet 9 is no longer just a hypothesis. It is the ultimate test of our understanding of the solar system. From the strange orbits of the extreme trans-Neptunian objects to the faint infrared signals, every clue leads to one question. Is there a massive planet out there hiding in the darkness? The Vera Rubin Observatory will provide the answer. With its ability to scan the entire sky and detect even the smallest movements, Rubin will determine whether Planet 9 is real or merely an illusion created by incomplete data. If discovered, it will mark a groundbreaking moment in modern astronomy. If not, we will be faced with another reality, that the solar system operates under gravitational laws we have yet to fully understand. And until Rubin completes its mission, this mystery will continue to challenge the limits of human knowledge. Thank you for staying with WUFO Space until the very end of this journey through the vast universe. If you found this video interesting and insightful, don't forget to like, share, and subscribe to WUFO Space so you won't miss our next cosmic adventures. Your support means the world to us and fuels our passion to keep exploring the wonders beyond.